What's up, Sci It's your boy Nickel coming at you here to explain what are muscles, or to try to answer that question, and I hope that you'll enjoy this journey. So, title your page, What Are Muscles? We're going to look at the muscular system and define what a skeletal muscle is. So, here we go. What are muscles? Good question. The muscular system is a system that provides movement, support for our body, to keep all of our bones in the right spots and to support us being able to stand up and sit up, and also heat production. That's right. Think about this. When you get cold, what do? You shiver. And when you shiver, you contract your muscles, and those muscles contracting actually helps produce heat. So the muscular system, which provides movement, support, and heat production, is also known as the musculoskeletal system. So this is a combination of the word muscle and skeletal. So it's also known as the musculoskeletal system because muscles need the skeletal system in order to do their work. So if we combine muscles and skeletal system, we get musculoskeletal, which is a big old word that just means the fact that muscles and skeleton, our skeleton system, have to work together in order for either of them to function. So if we define what a skeletal muscle looks like, we have to kind of draw a skeletal muscle. So let's dig in here and try to draw some part of our bicep. So we'll start with our shoulder. So we'll have like just a shoulder blade here, just going to give it a kind of weird shape. But our muscle is attached to our upper arm bone. And so I'll kind of just draw a bone here. And we're not really learning the anatomy of our arm, so it's not necessarily important that we remember all of these words of what we would call these bones. But essentially we have our bones, our upper arm bone and our lower arm bone, which we call our forearm, and then our hand would be attached there to the end. So if we look at these two bones, where they come together right here, we would call this a joint. And a joint is just simply where two bones meet. And in order to keep those two bones together, we actually have a ligament. Let's draw this with green. We have a ligament here that attaches those two bones together. And so if we were to look at those tissues right there that we call ligaments, a ligament is a tissue that connects two bones together. So wherever we have bones meeting with other bones, we have ligaments that help attach the bones together. And the muscle actually does that too. It helps keep everything together. So if we are going to draw our bicep muscle here, let's label that we're going to draw our bicep. And I'm going to use red here to demonstrate our muscle. So the muscle is going to be connected to the bone, to the shoulder, and both parts of the bone here. And then we're going to have our muscle tissue, which is kind of striated. And so I'm going to use these lines to draw this muscle. And so you can start to see the structure of the muscle that sits there on the bone. It's attached to the different bones so that it can actually, when it contracts and relaxes, it can allow this bone to move in either direction, in all directions really. Okay, so another word that's going to be important is a tendon. And a tendon is different than a ligament just because a tendon is what connects a bone and muscle together. So for tendon, we'll say that it connects the muscle to the bone. All right, so some important vocab words here that we have. We have tendon, which connects the muscle to the bone. It's kind of part of the muscle, but it is a bit more tough, and it doesn't change the same way that muscles change. A ligament is where we have tissue that connects two bones together, and a joint is just where the two bones are meeting. All right, so let's go on. Let's just scroll down a little bit more and write some information about muscles. So something that's important that we understand about muscles and muscle cells is that muscles need a ton of energy. So they have a lot, or a ton even, you could say a ton again, but muscles need a ton of energy, so they have a lot of mitochondria. Now, I said that quickly, but it's like, should make sense that if you need energy, you should have mitochondria, because as we learned last unit, the mitochondria is the powerhouse of the cell, which means mitochondria inside of the cell are what actually create the energy. Remember, the mitochondria are these little bean-looking things that kind of look like that, and they are what are creating the energy inside of all the cells in our body. So we would say that muscles need a ton of energy, so they have a lot of mitochondria in the cells of their tissue. Remember, cells make tissue, tissue makes organs, and the organ that we're looking at now, or at least the group of tissue that we're looking at now, is the muscles. So muscles are made out of tissue, which are made out of cells. So those cells that make up our muscles have a ton of mitochondria so that they can create the energy that we need in order to do work like picking up things or pushing or pulling things. So an example to prove this is if we look at the heart. Heart tissue cells, or the cells that make up the tissue of the heart, have they have twice as many mitochondria in their cells compared to a liver tissue cell. So a liver tissue is not necessarily as much muscle as a heart tissue cell is. A heart is made of muscle. A heart is mainly muscle. A liver is not really very muscular, so therefore heart cells need way more mitochondria than liver cells do, and when we look at those actual cells, they have twice as many mitochondria. All right, so the moral of the story is that muscles need the skeletal system in order to do their work, and muscles have a lot of mitochondria so that they can actually produce a lot of energy that allow our bodies to do the work that we can do, like sit up and jump and walk and crawl